So away we go. Minor, I will not be here tomorrow. You have just your lab. You just got to finish that up. That is due tomorrow, and then everything else is due Thursday. So a lot of you, that was due tomorrow.
Extra credit between
Okay. Here we go. Okay, there's a lot of things on here that you could definitely do, and I have the answers for all of them. So if you're ever like, I need to do a week acid, a week base, something like that, it's great. We're going to try to hit some major ideas. A lot of these can deviate from the problems, but a lot of them are really small, and I don't want to spend too much time on each part. So I'm just going to do one part of number 10, that whole thing. So it says that the pH equals 11.93. All I want, I just want to do one. I want to make sure that we're understanding this. It's funny, but of all the equations that we have, if I put them all back down and we put a box around it again, this is one that students do tend to have just a little mind hiccup, an issue that normally they wouldn't have. So I just want that one. Can you quickly calculate that? If you want to do the other parts of it quickly, you can. I'm going to ask a couple follow-up questions on it, but I just quickly want to do that. So 30 seconds, show your work. What do you have with that? So why I'm just bringing this up, and then I'm going to do a couple follow-up things. We have this as an equation, but if I already know pH and I want to solve for H+, hopefully you're recognizing that that's the equation we need. I hope. So you did. I got roughly this. Now, how can I get OH minus? What's one way I could do that? I want to talk about being flexible here. So, how can I get this? Okay. Okay, so you're saying 14 minus pH, I could get POH, right? And then take 10 to the negative POH. Okay. Tyler. So the answer that you just got, right? In essence, KW over H plus, right, will equal OH. Right? Both work. There's always one that's one more step. So Max's is one small step more than Tyler's, but the amount of work in general, I think we'd all agree, is probably almost exactly the same because one's just subtracting. You know, either one works out. And then if I wanted POH, from the beginning, what would we do for that? Well, that's right here, right? That's still just that. And if you wanted it at the end for some reason, like you forgot what you started with, you could take negative log of your OH, right? So just some ways of moving around. It's not like I'm acting like that should be a huge deal. Number 19. I want to throw this out here. More of kind of, look at it. It's on the right. If Cl minus equals 0.9, so concentration of Cl minus equals 0.9, what is PCl? Libby, what are you going to do? Yeah, it is like negative log. Whatever it is, P of anything is negative log. That's why pKa, POH, pH. So it's still negative log, in this case, of Cl. Now, are you going to normally see that? No, they're kind of writing more of a off-the-wall kind of question, just having you understand that if it says P, it's negative log. So that's as far as I wanted to really go with that one. So number 21, I'm going to leave it just for you to read and you to do. And then let's see where we're at. I just have a real couple real specific ones I want you to do. So go for it. I'm going to pause it. So 21 is what type of problem? This is strong acid. This is nitric acid. So there isn't a lot to this. You have 2.8 times 10 to the negative fifth molar HNO3. That means this is also H plus. It's the same thing. So I'm just going right in. By the way, I just realized this is the first time in 4 years that we don't have a test the day after Mr. PHS. We've always had a test the day after accidentally. We don't. For those that are going to. I haven't done that on purpose, it just always happened. So, I hope you got this. And that should be it. So, please recognize, I can't help you. I cannot help you on the test. If you're like, hey, I don't have a K value. You didn't give me one. I'm not even going to try to respond too much. And I don't want it to make it awkward, but I can't. Like, I'm just going to answer whatever is given to you on the test is accurate. I can't give away hints of if something's there or something's not. So if you don't see one, try not using it. If you feel like you should have one, it might have been stated in a previous problem. So that is legitimate. All right, so now let's turn it around a little bit. Let's go to 34. So I'm going to do this a little bit with you because 34 has a little bit extra pizzazz with it. So here we go. Calculate the Ka of a 0.06 molar weak monoprotic acid with a pH of 3.44. So I want to know the Ka by 0.060 molar of a weak monoprotic acid. So you could have a generic acid like that if the pH equals 3.44. Basically what I've been given. Okay? I would probably give you the actual formula, but if it just says weak monoprotic, mono means 1, protic is an H. So first, let's think about formulas here, or reactions. Something like that. Tell me something. If I want to find K, then what do I have to have before I can do that in general? I need molarities. All the concentrations where? All my E's, right? I need all my E's. So when you're thinking about this, this is where a icebox is really important. I want to make sure that you organize your information so I have it all. All right, so the only thing I know right now, if we agree on this or not, is this. Of actual given information that I don't have to do anything extra with. But I have more than that. What else do I have to know without doing any calculations? There's a couple other things. That's true, but I have to do calculation. But what else do I know about H+? What about here? These are zeros. It's more important than you think. Because I'm trying to create an equation here where I can get from the beginning to the end. So these are plus x's. Right? This is minus x. This isn't like the problem that we did maybe in class where I asked you, what did I start with? I already know what I started with. All I got to do now is get through the bottom. So now what do? Well, that's going to link here. Right? So I'm going to give you a second. Why do I know that's on the E? Because whenever I say the pH, that is linked to equilibrium. It has reached equilibrium, and that's why it has distributed as much H plus into solution as it can. Okay, so give it a shot. Calculate your K. Let's see if you get what I get. But I'm going to give you a moment to calculate it if you haven't already. So that would be my general setup. If you're still working on it, great. But I'm just plugging them in. I shorten it up. If you don't feel comfortable with that and you want to put them both on top, that's fine. But those are going to be squared. They're on the top. They're products. Products go on top. Reactant goes on the bottom. Don't forget they're being subtracted. I haven't calculated this yet. Let's see. I got this. Okay. And the answers are in the back. You can definitely look at it. But that's if I'm ever solving for k. I can totally ask that. We have the ability to move through. To be honest, if I ever am solving for k, I think those are always easier because that means I'm already given a huge clue that I must know all of this just from some simple subtraction or addition in one way or the other. Okay, so I don't mind those at all. Again, any questions, just throw them out. Let's go. I wanted to do one of those, though, that brings us down here. I know on the acid basis, too, you have at least one of those like that as well. So keep an eye on that. But let's look at the next one, number 35. Okay. So we've only done one of these. And you got to think about what's happening. So let me write out the situation. This one's going to take a little time. Okay, so it says what is the pH of a solution that contains, and then you have two of these. This is sulfuric acid. This is actually acetic acid. Acetic acid, if you rewrite it, you don't have to, but it also looks like that. This is the more common way of writing it because in our orgo chapter, the ending is a double bonded O right here with an OH, so that's a carboxylic acid. It's more real. It's a better view of actually what it looks like versus having it in ionic form. This is what it looks like more often than that. I'm combining two acids. This is just like having a diprotic acid problem, though. This is actually how I showed it to you first. I did a problem when you have a mixture of acids. And if you don't remember it, we ran out of time. I haven't had a time to work on it since, to be honest with you. We need to track H's. That's all you got to do. So which one do you calculate first, the stronger or the weaker acid? Stronger. Really strong. It's a strong acid. Now you're like, oh, that's a diprotic. If they don't give you anything like this, where it says like Ka2 or Ka1 and a Ka2, then we can assume that all this is going to come off of the first H. Okay? So let's set this up. This is a good one to have. Again, we don't have a test in 2 days. This is just good to see it. So then you're, okay, if I mix this and I have another example in my notes, I can do this. I'm going to write it like this. Even though technically, it doesn't really matter what I write on the right side as long as I'm making an H. So I'd rather make it like this. And I'm going to assume that the rest of the H's, in the test, a valid test question would probably have to tell you, like, assume all the dissociation from the first H, or from the first dissociation, all the H comes from that. Notice I'm doing a single arrow. So this is a strong acid. Actually, I'm going to write it right there, just so you have an understanding of what you're doing. That's a strong acid. I'm going all the way. That means I don't worry about how far it's going to come back. That means I don't need a K. This doesn't really require an icebox. Because if I have point, I'm going to write it here, but this is kind of pointless. Because then that means all of these are the same. Like it's all there. So that's the important one, right? The H plus. That's what matters. Okay. So why did I do that? I did that mainly for the second part. So I want the pH. Well, pH is the amount of H plus left in a solution. So this is the one that matters. This is the one that's going to trip you up. This first acid donates that much H plus. Now I take this, acetic acid. Because it's an acid, I don't need to react it with water because it's getting the H from itself, right? It's donating it. And that's just my equation. I hope, I know some of us are still struggling with equations in general. Keep looking at how I'm doing that. I'm usually taking, if there's an H exposed at the end, somebody had a question at one point, how do you know which H you're supposed to take? If there's one exposed at the end, the reason why that one's taken is because that's that little OH hanging off on the end. We take them off of functional groups if possible. Okay, so what can I fill in here? Let's just view this completely. If you don't know what you're doing, do as much as you can in an icebox. Like, that's not the time to go, well, I'm probably just doing this. Like, the more you know, the less you have to do the icebox. If you're unsure, fill in as much as you know. So give it a shot. Fill in as much as you think you know. And if you can move forward without me, awesome. But I'm going to ask you to help me in a moment. What can you fill in? Now I made this one, or they made this one easier because the first one was a strong acid. If this was a weak one, right away I'd have to do an icebox. I'd have to make it equal K. I'd have to find X. And then X would be the final two things on the right side, as an example. All right, what do I know? What's one thing I know? Grant, what's one thing I know? Here? Okay. Anything else I know? There's one more thing I know. Yeah, Ashley.
Isn't the H plus 0.25?
Good. It carries through. And then what about the acetic ion, or the acetate ion, sorry. What's that? That's 0. Remember, initial, if you don't have it, you don't have it. That is an assumption that we have to be able to make. So now this is normal. This is just an icebox now with something on each side. I know these are positives. The reason why is because of the 0, right? I know that has to happen no matter what. Even if you have the smallest K possible, you have this huge negative exponent, meaning it's going to drive it to the left. It's still going to go to the right to make a little bit of that. A little bit. So now I have all my expressions written out in my E, my equilibrium, and now I can make it equal to my K. So I do this. Am I going to have to do a quadratic? What's your guess? Probably not, because my original amount is well over 100 times greater, or was brought up today in class. Your packet says multiply it by 400. Either way, it's not going to make it. I cannot foresee that. So we always assume, though, you can always check it later. So you cross those off.
How do you know to use K or find K?
It's a great question. This is an acid, right? So that if they gave me a K, the only time you're going to have to use something else is usually in a SELT problem, which we'll try to do yet. But this one's clean. Like if you're like, that looks kind of like an acid, then yeah, it's an acid. That would be it. And I cannot say X equals H plus. Tell me if I'm not getting something you got. So the key to this is, and I keep running into problems that don't contribute a lot, but it's still about the work, even if it's not coming out right. I can't imagine that does anything to it. Yeah?
How come you don't have to double the molarity with the H2SO4?
Yeah, because, and I kind of hinted towards that in the beginning of it. The problem should or would normally state something like assume all of the hydrogen or the hydronium ion is the result of the first ionization. Technically, this H is still in this. So I would need to have, they would have had to given me a K for me to be able to do the next one. So it's not just simply, oh, it comes off as 2 like a hydroxide. It's different. So it's totally valid. Like, wait a minute, when we do strong bases, it's doubled. It's not the same. It's because with an acid, once one H comes off, that's not a strong acid anymore. You know what the real difference is that strong bases are technically salts. And salts are soluble, so they're going to completely break apart no matter what. These aren't technically salts. So once you break one off, this thing doesn't give it away as easily. Okay? and that's confusing too. It's like, wait, when's the salt problem then if it gives me a strong base? Does that change my value of H? Does it at all?
Like, yeah,
I mean,
that was 0.250072.
Yeah, you're right. But sig fig wise, unfortunately, it doesn't. But it's important to show it. So now I can just move forward, and basically it's still that. Right? You can never assume that. If you do use the other number, it's 6.6019 for a pH versus 0.602. Basically that. And it's really small. I'm not surprised. I started with sulfuric acid. It also shouldn't be totally shocking as you do a problem like this, though. It's like, well, wait a minute, why didn't the other one contribute? I just started with sulfuric acid. It's going to give me so much H that this next one can't do that much for me anyway. The better test question would be 2 weak acids, which you have an example of in your notes, where you'd have to do this on the first one, and then you'd have your X's be your H and your HSO3, let's say, and then that H would come down on the next one, and it would be a lot less. It'd be a much lower number. All right, let's change gears and see how we can just bounce around and do number 50. So give it a shot. I'm not going to say anything again. Can you calculate this? And then we'll get into some other kinds of problems. I got about 3 more in my head that I'd like to do, but I got to make sure I find them. I'm going to pause it. So finishing up. What is the pH of 0.5 molar solution of dimethylamine? Let me give you some information. Some of you are going to think maybe it's a salt. To me, this looks like just a weak base problem. Okay. And the reason why, if you're like, how do you still know that? I don't see any metals in the solution. It's not a salt type name of a salt. Like that's not the way that it would work. So I got to just trust that that K is of that compound, and it sounds like it's just a pure weak base kind of problem. With a base, I have to react that with water. And if you're sitting there, well, yeah, it didn't ask me for an equation. You got to always be ready for the question of what is the dissociation reaction, or what is the reaction in water. I'm going to have a few of those, so you need to be able to show me it. Okay? So by doing that, it's going to make OH. The reason why I know that is it's a base, so it's got to make OH. If you want to make it easier or more difficult, you can also say that the base has to gain an H. So it's got to gain an H on the other side. If you didn't know where to put it, I'm showing you now. That's what it should have looked like. So before we move on, let's actually, because I don't want to do a separate problem. I looked around, I didn't see one. Can you label A, B, C, A, C, I don't know in what order. Can you label them above or below on that equation right now of acid base, conjugate acid, conjugate base? Would you be able to do that? Because there's going to be a couple problems like that on the test. Easy points. Can you identify each part before we get into the actual problem? And I'm not saying this one's easy or hard, it's just it's in front of us. Should have that. I hope. Once you get one, it's done. If you can just find the pairs and you figure out one, there's not a lot of leftover thought because they have to be opposites. They have to be opposites on the one side, they have to pair up and be opposites with the other ones from the left to the right. Okay, so again, an icebox is there for you to do as much work as you need and not more. So I have 0.5 molar of this, and this one kind of is more or less done already. There's not a lot here. This is just a classic straight up weak base problem. So if you felt like you needed all this, I'll just show it. I want to show something here. I'm going to check it. I am not feeling 100% on this. Well, I don't have to check it. It's not happening. I wrote that down wrong. It's 0.017, isn't it? I'm like, I don't remember that being that close on my calculator. And then I'm like, wait, whoa, they're right next to each other. I still don't feel great about this. Oh, I didn't feel good about that. I'm okay. Am I wrong?
How come we don't use find K? It gives you KB.
Right, it's a weak base, so I already have the K. So if you guys were finding another K, you were thinking this is a salt. This is a base. Yep. So you're like, how do I identify it? As I was kind of talking in the beginning, this isn't a name of a salt. There's no metal in here. You got to be able to identify the difference between it. So we can keep trying to work on that a little bit if we need to. I feel good. I do not need to do the quadratics, so that's my value right there. And now I just go forward. I establish that I'm solving for POH. So it's 1.76. Awesome. Oh my gosh. Oh my gosh. So then I get a 12.24. That's right. Yellow. Good. All right. Any other questions on that? I picked that because it is one of those. It's like, wait, is that a salt? Is that what's happening? Just a weak base. Okay. If you have them, that's great. But throw them out. Going off of that, I want to do number 39. If we have time, I want to do 38, and then I have one more for sure. And I don't want to go over time for you. I know you guys have been working on these a lot. So let's do 39. So I want to know the pH of a 0.2 molar NaH4Cl solution, and then it says Ka equals 5.6 times 10 to the negative 10. What type of problem is this? Strong acid, strong base, weak. Salt. Salt. Libby's on the test. She gets to the problem. She's like, salt! Everyone's like, whoa, which one is she on? And that's when we knew she had Tourette's. All right, start working on it. What's difficult about this one is that they don't tell you what that Ka is. Okay? So it's not as a dummy switch of just throwing a formula down. Like a lot of times I give you like a little extra formula right there of what that is. So you have to think about how this breaks off. So this is going to be NH4 plus and Cl minus. Only one of those ions can be in my equation. Okay? I will say this. Well, let's talk about this. What is this going to be, acidic or basic as a solution? Acidic, because NH4OH is not a strong base, right? But HCl is a strong acid. You can't have a neutral in this. So if you're like, well, I know that's a strong, well, then you're done. Like if you know one is a strong, you're done. So it has to be acidic. Has to be acidic. So you can think about this. So there's only one that makes sense. And if you put this here versus putting ammonium here, only one makes sense. Why does only, like, explain to me why I have 100% confidence in why I picked the one that would be the right one based on the nature of what just happened to water. Cl? What happened to my water? The gain in H doesn't come from anywhere. Where does it have to get it from? Had to get it from something that has an H, right? Has to get it from somewhere that has an H. So, we gotta slow down and just look at this for a second, because this is bizarre. They didn't tell you what this is yet. I'm doing this for the first time with you as well, so I'm just recognizing something. This problem is what right now, acidic or basic? It's acidic, right? So if I don't look at this, like, don't think of this problem. If I tell you I'm doing an acidic problem, you need a Ka. If I'm doing a basic problem, you need a Kb, correct? Okay? So, do I have the proper K already? Yeah. What they did, this is why they didn't probably tell you this, they gave you the K, I'm discovering this for myself right now, of that. What you would normally see, just so you see this, from me and from normal AP problems, is this is what you would see. And I have this one memorized because it's used a lot. And I'm going to guess that that actually works out perfectly to that other one. There it is, okay. So this is actually, if you want to fill at least that in, this is of NH4+. That normally isn't supplied because that's not a real, it is a thing, but it's not an acid. It's not a, it's a base. It's like a conjugate partner of a more well-known acid or base. In this case, it's a conjugate acid of a well-known base. So, it's actually a really good question because what you got to realize is, oh my gosh, wait, I'm already an acid. I already have a Ka. So if you ever get to a problem and you're still doing salts and maybe you don't know you're doing a salt, and you figure out the OH or the HOH to the H3O plus or the OH minus, you just got to look at it and go, wait a minute. I'm saying that it's a base or it's an acid, and they gave me the other K. I need to get the other K now. Oh, wait, I'm saying it's an acid, and they gave me a Ka. Awesome. So this problem's not as much work because of that. So now I just fill this in, and you can put as much as you like. I cannot urge you enough to at least do that much. At least show me what you know in the beginning, and you've established this. We are at a point where obviously this is going to be, in this case, and I don't want to say obvious, but we've done it a lot. If you have initial and nothing else, this is x squared over initial minus x, right? So now it's basically, let me take this home. That was a little bit of a twist. I wasn't ready for that either. It was exciting. Due to time, and we did one today, I just want you to see, I marked a couple of these. We're going to do one more yet, but I'd suggest doing number 38. I'd suggest doing 46 and 47. This is me. I would try to do a couple more of those. All that area though, 14.5, the whole bottom half, 14.5 through 14.7 has some really good stuff in it, like really good, like very test-worthy kinds of questions. But I wanted to work on, to finish today, And there's a ton of multiple choice. I mean, you can pick whatever you'd like. But I want to do number 55 to finish today. And then we'll be done. As always, I don't want to ever go over for you. This is extra time, you guys. Wise though. So it says, what is a pH? And they give you all this already, and they actually set this up really nicely for you. They didn't have to do it like this. They didn't have to give you all the equations to understand this, but I'm going to write the first one right away. So arsenic acid. And then they give you the Ks. Suggestion, when I'm doing this, and I probably should have tried to model this right away, is I try to put this as far to the left, and I'm going to do the work on the right. When you're realizing this is, I don't think this is a giveaway, but if it is, if you're doing a polyprotic acid, you need to set up ice boxes, but also you need to do a little bit of work. So I do the work to the side. Don't do it below. Do it to the side. And we're going to try to just keep this organized as much as we possibly can. So away we go. I have 0.1 molar. The first one's always the easiest one. The reason why is that you are starting with only one ion or acid or base, acid I should just say, and it's just dissociating. That's all it is. But I'm going to just write it all the way. I think it's good just to see it one last time. There's nothing more to this though. And then you make sure, it shouldn't be that hard to do, but just don't mix these up. So then I put it to the side. Start up high. Don't bleed down. I mean, if you have space, you're not going to go back up. Don't take for granted the space that you have, and also don't use it all up because you just feel like you don't need the space. You never know what you're going to need later, so try to stay consistent on the size that you're working with. So I got 0.1 times 6.0 e negative 3 to the square root. Suggestion, when you know you're going to be carrying this through for a while, rounding's not as good of an idea. Your final answer needs to reflect sig figs. I'm not also encouraging you to make some ridiculous number here, or there's a ton of them, but it's not a bad idea to leave a couple extra ones. I'm even going to go one more. I am not certain about this, so up in a corner somewhere. So is that going to be okay? Be 2.4%, right? That's if I'm seeing that totally wrong. Am I wrong? Tell me if I'm wrong. It's 24%. Okay. So what do I have to do? I was hoping we'd have one. That's actually, it was not a very heartfelt smiley face, to be honest with you. I have to undo this. I always assume though. So I just erase this. And now, reminder, I need to get into this. This is the sole reason why I'm wanting to do a problem like this. Whoops, I didn't do that right. My gosh, I'm falling apart. Okay, so please, you need to extrapolate this out, make it equal to 0. Let's talk about what we need to get done. I'm going to pause it, so get it in the quadratic. Anybody get a relationship? Just the, I didn't do it, so. Do you have it? Brooke, do you have the
That answer?
No, the AX. Like, did you write it out like that?
Yeah.
Okay.
Oh, jeez. Okay. Negative. What do you want me to do?
Did you like extrapolate this out into this format?
Yeah.
Yeah.
Negative x squared.
Okay.
Minus 6.0 times 10 to the negative third x. Plus 6.0 times 10 to the negative fourth.
That equals 0?
Yeah.
Okay. I wasn't ready for the negative. It threw me off. what's the quadratic formula? Is this right or wrong, Andy?
No, it's right, it's just, look,
You get
I had
a
it
little bit
flipped,
bigger
yeah.
with
So that.
So you had
that-
this, this,
Yeah.
and that. Oh no. Like that. Either one will work.
That's fine.
It's all good. What's the quadratic formula? What's the quadratic formula?
Negative b plus or minus the square root of b squared minus 4 times a times c over 2a.
I swear, I was told years ago that either a math teacher here or in middle school taught you guys a song about it. And, that's what someone had told me one time. Okay, what do I get? There's two options. You got them both?
I just take the positive one.
Okay, what did you get for positive?
0.0217.
0.0127.
217.
I am dying here. 0.0217. Now my zero looks like a weird acorn. Actually, that's a good looking acorn. Can do that, but try. Okay, so that is great, and that hopefully is the last time we have to do that. If you want to talk more about that, we definitely can, but give it a shot. I don't know how you all approach it. To me, I would try to get the b squared minus 4ac in the square root of that, and I get a value, and then I would plus or subtract and add that to the negative b and go over 2a and do the opposite. That's what I would do. If there's a faster way that you have, great. Then we got to keep moving forward. So I'll tell you now, that's generous. Them giving you all the equations, I would not do that. I am not nice. You don't want to start rumors. So I have this, and now I need to understand it. I normally would write h plus, but I'm going to mirror what they're doing in the packet. So remember, every time you take an h away, it becomes more negative. Every time you add an h, it becomes more positive. So that's my second equation. The whole point of this now is more of an exercise to make sure we are understanding what goes where and how we calculate this. So hopefully the rest of this goes faster. I'm praying that we don't have to do another quadratic. I don't want to do another one. Well, I didn't really do the first one, but you know what I mean. So what do I know right now? I know the H2ASO4 minus, right, because that was from before, and that's 0.0217. Be careful again, if that's really severely rounded, you might want to have another digit. I don't know what it is, but if it was like a 5 here, I might want to keep 6 and a 5, just to have a little bit more integrity in my number for now. And then what is the other one that I know? H plus. The important part today is that are you recognizing how this carries through? And then this is 0. Okay. Now the second one's awesome. I love the second one. And if you don't remember how, or you're not seeing how this is going to play out, I will show you in one moment. Love, love, love the second one. It always happens like this, if it's just a pure dissociation. So I come over here, and I'm going to plug it in. Do not underestimate, again, the importance of potentially getting points by plugging it all in. Don't assume that the work can be done without you showing the work. Oops, and I'm sorry if you were copying this exactly. I did not do that on this side. I look up the K. It's just right there on my sheet. And what happens with this? It happens like this every single time in the second one. X equals the K, doesn't it? Okay? And the reason why is that first off, we make that assumption. Okay? And then mathematically, that's gone. So, X simply equals 1.05 times 10 to the negative 7. Do I need a quadratic? Like, I could show the work here, but do I should feel pretty good about the fact that 0.0217, that'd be times 10 to the negative 5th, versus that. Again, about 100, but if you're over 1,000 times larger, you're definitely, bless you, you're definitely safe. If you want to check it out, you definitely can. I'll even do it just on my calculator, and you could just do it on your calculator. Take 1.05 e negative 7 divided by 0.0217 times it by 100, and yeah, It's still 4.84 times 10 to the negative 4%. We're good. All right, so to finish up, Anissa cannot get any bigger than a triprotic. I take the last ion that can act like an acid, and an acid gives away H's. If you did not, if the values are even getting smaller in the K's, you're probably really safe. So the only time you're really going to need to do the quadratic is the first time, if that is where you're going to be required to do one. And now I need to make sure I do something though. And it's really important. What is the one that gets the 1.05 times 10 to the negative 7? Where does that go? The HASO4. Did I write that right? Yeah, I did. Why can't that be the H plus? Now, it might be the same, and it's kind of looking like it's going to be. But still, you got to just realize it and be careful. Usually that's actually kind of surprising that it doesn't carry over a little bit. I didn't create the problem. But you should show it on the side at some point just to show that you've done that. So right here, I'm just doing it right now. But I cannot, I'm just going to do it. I'm paranoid because this is the stuff that I assumed always when I was, but regardless, it's important for you to see it's not the 1.05 times 10 to the negative 7 anyway. It's the other value. So I can see someone in your mind right now going, oh, it's not going to affect it at all. And then you accidentally bring this one over. You know what I mean? It's like, oh, it didn't do anything. And then you bring in the wrong number. Make sure you're bringing in the value. Then this is 0. We go forward one last time. And I hope that you're seeing how this works. I think it's so important to make sure that you're doing your work on the side of each icebox so then it's not confusing where you're putting that work. So I have x times 0.0217 plus x over 1.5 times 10 to the negative 7 minus x equals. I cross out the things that I can cross out, which are things that are added and subtracted. Holy cow. Anybody else get this? Okay, I'm a little disappointed. I'm sorry. I assumed if they had printed a problem in here, it wouldn't have been so severe that I assumed that there was going to be adding some H's. I really did. Like, I didn't think I needed to draw. The minute I saw that that one was in there, I thought that I was safe and I didn't need to come up with one myself. It's still important to show it. I'm disappointed. But I still show it all. And then, it does need to be said, after all that work, it's amazing how many students stop right here. You still got to find pH. It's like, you just did all of that and you didn't find pH. You cannot assume first off, like, oh, I'm just going to use the first H. Unless they tell you that. Like, hey, all the H, assume all the H comes from the first ionization. Unless if it says that and I didn't read it carefully. I'm going to be really upset if that's the case. Oh my gosh, I could totally see it saying that. Now we do that. So, for tonight, the important part is for you to just remind yourself, okay, so I bring it down each time. Each H has its own unique flavor, if you will. The first one is just the classic x squared over initial minus x. The next one you're actually going to have be, it's always going to be x equaling that if nothing else is happening. But you need the icebox because when you bring it back, you need to add it. So it's not like, oh, I won't even do the icebox because I know what this will be. You need to have that there. And then the final one, now you're having new values from both sides. Okay? So you will be having time in class tomorrow to work on things. The lab is due tomorrow by the end of the day. You just have a couple questions at the end. Make sure you match them up. So take those negative logs of those KAs and see if you got it right. Everybody's I've seen so far, it seems to be matching to something. But I haven't seen a lot of people's.